Hello and welcome. In this video, I will show you how to configure Prometheus for a high availability and long-term metrics retention using Thanos service. All the configuration files discussed in this video are available at my blog site as well as on my GitHub repo. Check the comment section for the links. Prometheus stores metrics in a local TSDB database, and this can grow very quick. And also it's a problem if you want to store the data for many weeks, months, or maybe even a year. And the TSDB database could be so huge, and when you try to query any data, it'll be very hard for Prometheus to return, and it will be very slow. Prometheus will also require a lot more memory and CPU resources to even function with larger TSDB database. That is where Thanos comes in. Here is a high-level architecture of Thanos. It has multiple components. There will be a Thanos sidecar that will be installed alongside Prometheus. This sidecar will be responsible for uploading the TSDB files to object storage. And then there is Thanos application. So the query frontend is a add-on, optional add-on. If you enable that, you will get a better performance in terms of query. Querier is responsible for aggregating all the metrics from multiple Prometheus and deduplicate them. Also responsible for getting the data from Prometheus as well as from the S3 bucket via storage gateway. Storage gateway is responsible for reading the data from the S3 bucket. So when the querier requests the data, storage gateway will go retrieve it from the S3 bucket. Compactor is responsible for deduplicating and compressing the data that is stored in the S3. I have already prepared a EKS cluster and installed standard Prometheus. I have a single copy of Prometheus running, and it got two containers running, one being config reloader and the other one being Prometheus. I also installed Grafana. There are two parts to configuring Thanos. First part is configuring the Thanos sidecar with Prometheus. The second part is configuring installation of Thanos application. In order to configure the Prometheus sidecar, Thanos requires an S3 bucket and also permission to write to that bucket. Since I am running it on EKS, I will be using AWS pod identity for allowing the Thanos sidecar to write to that bucket. Step 1 is creating an S3 bucket. I have already created an S3 bucket called EKS autodemo-thanos. So step 2 is creating pod identity. Here I'm creating a policy that will allow write access to the bucket. So you will get S3 list, put, and delete object. And I'm creating a IAM role, Prometheus Thanos role, and attaching this policy. Then I'm creating a IAM access identity for this particular role. Let's go to the console and check. So here is my EKS cluster. And if we go and check the access control, here you can see I have created a pod identity association for namespaces monitoring and the service account kube-prometheus-stack Prometheus. I'm installing the Prometheus from kube-prometheus-stack, and this is the service account kube-prometheus-stack uses. As you can see, this is linked to a Prometheus Thanos role. This IAM role does have permission to write to that particular bucket, and also got a trust relationship for assuming the pod identity. Here I have my original Prometheus configuration. I will uncomment the Thanos service. So I'm enabling the Thanos service, and I'm also enabling this Thanos service monitor along with some additional labels. So in the Prometheus spec section, I'll enable the Thanos configuration. So here I'm specifying the Thanos image name and also the object storage config. This is where you specify which object storage and name of the object storage, region in which it is located. Let's go ahead and update the Prometheus configuration with Thanos. So I'm already in folder with my Prometheus Thanos YAML file. I will execute Helm upgrade with the current configuration. So Prometheus is coming up, and notice the number of containers within this Prometheus pod. So there are 3 pods now. If you check the configuration, you can see There is config reloader, Prometheus, and Thanos sidecar. So let's go and check the S3 bucket and see what has been added to the S3 bucket. So as you can see, my S3 bucket is empty. This is perfectly normal for a fresh installation. Thanos will upload the file when Prometheus closes the current TSDB file. So Prometheus generally closes a TSDB file every 2 hours or so. The part 2 is installing the Thanos itself. Thanos storage gateway and Thanos compactor require access to S3 bucket. We have already created IAM role and IAM policy that will allow write access to the S3 bucket we created. With pod identity, we will be able to reuse the same policy. Here is my Terraform code for creating pod identity association for compactor as well as storage gateway. Here you can see the namespace is Thanos. That is where I'm going to install the Thanos application. And the service account is Thanos compactor. This is the service account used by the Thanos compactor application. And for the storage gateway, namespace is Thanos, and Thanos storage gateway is the service account. I have applied the configuration, and this is the EKS console. Now you can see there are additional pod identity association. Here there is a association for service account Thanos storage gateway and Thanos compactor, both in the namespace Thanos. And I'm reusing the same Prometheus Thanos role because this role has write access to S3 bucket. Now we are ready to install Thanos. Here is my sample Thanos configuration file. I'm specifying the default storage because Thanos services require a local storage. I'm also specifying the allow insecure images equal to true. This is because current version of the Helm chart points to Thanos images in Bitnami, which is no longer available, and I'm having to update the latest registry location. That is the reason I'm having to add this entry. Then here is my object storage configuration. This is the same as the one we added for the Thanos sidecar. Thanos installation will create a secret with this configuration file that can be used by all other Thanos services. And here in the Thanos query section, I'm enabling the Thanos query. By default, Thanos query looks for a replica label of replicas. If you are installing a kube-prometheus-stack Prometheus, the replica label is different. So Prometheus underscore replica is the label which you have to pass to the query. And I'm enabling the DNS service discovery, and this is the service name exposed by the Thanos query service. I'm also passing it as an extra argument for the Thanos query. I'm specifying the resources and enabling the monitoring. And when it comes to storage gateway, I'm enabling it, and single replica, also specifying the object store configuration file. This will be generated from the secret we created earlier. In terms of compactor, again enabling it. You can configure the compactor for required retention period. And in the extra argument, you also specify the object store configuration file. I'm enabling the self-monitoring of the Thanos compactor as well. I'm also installing a query frontend. This is an optional component, but is also nice to have. When you have multiple queries running, the Thanos frontend will be able to load balance between the queries and also cache the queries for a better performance. I'm not enabling the receiver, ruler, or bucket web. Thanos Helm chart is stored in Bitnami. I have added the Bitnami repo. So here you can see I have the Thanos YAML file in the local folder. We'll go ahead with the Thanos installation. Thanos compactor, Thanos query, Thanos frontend, and Thanos storage gateway. All of them are starting up. So my Thanos service is installed and it is ready. I'm doing a port forwarding for Thanos query frontend. And here you can see this is the Thanos query frontend. This looks very similar to Prometheus, but you can see the additional option of use deduplication. So when you have multiple Prometheus instances scraping metrics from the same sources, you end up with duplicate data. And Thanos querier will be able to deduplicate and provide you the metrics. This works very similar to Prometheus. If it is connected to the Prometheus properly, you should be able to start typing in and you will see all the metrics being collected. So we have configured our Prometheus to have a retention of 4 hours. So if you need to query anything older than 4 hours, it will go to the Thanos service. In Grafana, I configured a data source called Thanos. and that is pointing at the Thanos front-end service. You can see I also have a Prometheus front-end. Here is my EKS cluster data, and the data source is Prometheus, and let me change the data source to Thanos, and you can see both are the same. This is because at the moment all the data is coming from Prometheus itself. Prometheus has the data for 4 hours. If you say go for something like 24 hours, in my case, my cluster has not been running for more than few hours. The only data available is in Prometheus. Here is an example from a running cluster with the Thanos. Here I have the Prometheus data source. And let's say I want to get the last 12 hours of data. As you can see, Prometheus only stores 4 hours of data. If you need more data, you will have to query the Thanos server. So Thanos server will get the data from Prometheus for the current data, and for any older data, it will go and fetch from the S3 bucket. So here is a result when I select my data source as Thanos. So here you can see the data is available for more than 6 hours, 12 hours, 24 hours. Until now, we were running single Prometheus instance. That is not good for a high availability. For example, if the node fails, your Prometheus also fails. You can always run multiple replicas of Prometheus instances. Both instances will scrape all the targets and send the metrics. Thanos will upload the metrics to the S3 bucket, and the Thanos courier will do the deduplication. If you're using kube-prometheus-stack, running 2 instances of Prometheus is not enough, because by default, Prometheus stack does have a pod anti-affinity that will enable 2 Prometheus instances to run in the same node. That is not ideal. So in order to overcome that, when you increase the number of replicas, you also have to define pod affinity as blank. So this will disable the anti-affinity, and then you define the topology spread constraints. In this configuration, I'm putting a topology spread constraint based on zones. So 2 Prometheus instances will run in different zones. So that increases the availability in case of zone failure. External labels is something you can add if you are sending the logs to a centralized Prometheus server. Thank you, and I hope you find this information useful.